A function f is defined for x less than or equal to 3 over 2 by f of x is 2x squared minus 6x plus 5. So we want to express f of x in the form a, x minus b all squared plus c, where a, b and c are constants. In other words, we want to complete the square. So 2x squared minus 6x plus 5. So the first thing I'm going to do is take a 2 out of the first two terms and then have x squared minus 3x. And the 5 I'm just going to leave out there. So this process is fairly routine. We have a bracket with x and then half of the coefficient of x. So 3 over 2. So this is 3, so 3 over 2 is half of that, including the sign, so negative sign, and we square that. Now, if we actually expand x minus 3 over 2, x minus 3 over 2, we get x squared minus 3x, and both of those we want because we can see them here. But we also get 9 over 4, which we don't want. So we're going to do take away 9 over 4. And don't forget that plus 5 is still sitting there. And so we have twice x minus 3 over 2 squared. I'm just expanding the bracket now. Take away 9 over 2, add 5, which is, and remember 9 over 2 is 4.5, so that's twice x minus 3 over 2 squared plus a half when I put these two things together. Okay, so on the same axis we want to sketch the graphs of y equals f of x and y equals the inverse of f of x, showing the geometrical relationship between them. Now that geometrical relationship, of course, we should know. Now, it was defined for x less than or equal to 3 over 2. So when x is equal to 3 over 2, this bracket here will equal 0 and we'll just have a half. So if I use each of these marks here to be worth a half, that would put that just there, 3 over 2, a half. Now when x is equal to 0, we'd have 9 over 4 times 2, so that's 9 over 2 plus a half. So that's going to be 5, and clearly I can't fit it on the scale I started with. So 3 over 2, a half is here. 0, 1, 2, 3, 4, 5 is just there. Now if we look back at this original thing, this is the minimum point here of that. We know that the completed square form gives us that. And then it's a quadratic, so we know the shape of that. It's going to go like this. So that's y equals f of x. Now the next thing that we need to add onto there is the line y equals x. And then the inverse function is the reflection in y equals x. So where we've got 3 over 2 a half here, we'll have reflected across a half 3 over 2. So that's going to be sort of there. And 0, 5 reflects across to 5, 0. And they must meet at the same point there. So it's going to go, I started that very well actually. Oh no, got rid of, so that's y equals x. Let's put the original curve back on, like so. Not very happy with that either. You get the idea. I'm sorry this video is becoming such a mess. And so it's going to go there. And that was the turning point. And then it will come down like so. I still would actually redraw that in an exam, but I'm not going to fiddle around with it. You get the idea. Okay, so using the answer from part 1, find an expression for the inverse function. So I'm going to let y be equal to, so that is 2 x minus 3 over 2 squared plus a half. And then we'll interchange x and y. So x is twice y take away 3 over 2 squared plus a half. And now we want to make y the subject. So twice y take away 3 over 2 squared is going to be x take away a half. And then y take away 3 over 2 squared is going to be a half x take away a quarter, and I might just take a quarter out there and say that that's 2x minus 1. And then y take away 3 over 2 is going to be plus or minus the square root of 1/4 2x take away 1. So y is going to be 3 over 2 plus or minus the square root of a quarter is a half, so I can bring the half out there and have root 2x take 1. And we're going to have to make a decision between the plus or the minus. So, well, the highest point on this one is 3 over 2, and then it goes downwards. So I think we're going to have to choose the negative. So f minus 1x is going to be 3 over 2 take away a half of root 2x take 1. And the domain for that would be the same as the range for the original function. So if we look at the original function, it starts at a half and goes upwards. So x is a real, x is greater than or equal to a half.